With every dollar you spend on reasoning or thinking tokens, you are making AI answers worse. This is not my opinion. Google just proved that longer thinking will let AI models be dumber. That's why they came up with a new metric called deep thinking token, which they use it to create a solution to let AI answers be much more accurate, but with just half a cost and with no need of all those prolonged chain of thoughts or reasoning tokens. In this video, I'm going to show you what is the idea behind this solution, which is fairly simple, and how you can use it right now to gain the benefits in your own projects. Let's check it out. We have been mostly told that chain of thoughts, or when you have reasoning tokens getting prolonged, there's a greater chance that the answer gonna be more accurate because it let my AI model think more and come up with a more accurate response. This is no longer true. You might argue and saying that no, chain of thoughts is still there. For older models, potentially that was working up to a level, but for recent ones, check this out. This is the paper published by Google. On the left side, you can see that when you increase the amount of tokens getting generated in the answer, the accuracy is getting dropped. So the correlation between the accuracy and the token count has negative correlation. It's not even good or positive, it is negative. And they did this multiple times through different models, which we're going to talk about which models, and can see there are different colored lines. Each color represents a different use case. So they're mainly scientific and mathematical use cases. They tackle that to see if that reasoning capability becomes better. This is not true. But on the other hand, what they tried, instead of just measuring how long, they measured how deep that token generated is. And I'm going to talk about that, what does deep thinking token means and how they calculate it. But just keep it for now, that when they go and switch the metric from token count to deep thinking ratio, as we see these deep thinking tokens gonna get more and more, now we can see the accuracy is also getting increased, and we have a strongly positive correlation between these two. So this is a hint that we need to shift our mindset. When we talk about deep reasoning, we should go beyond just length of tokens. We should see how deep are tokens. So what is a deep thinking token? Deep thinking tokens means if a given token that is generated in the answer, how much it was really involved in calculation of inner deep layers of the model. Was it something for the model to quickly predict, oh, this is going to be the next token in the answer, or no, it takes time to get stabilized. So to give you an example, I just talked about the fact that more tokens doesn't necessarily mean that we have a higher accuracy, because models suffer from overthinking. So excessive reasoning often amplifies flawed heuristics and waste compute on uniformative generation. But on the right side, the reality is, as we get more tokens, we might get accuracy getting increased, decreased, but on average, this is not what we see and what we believe with chain of thoughts was the case, not necessarily. So instead of just having this rudimentary vision of longer the better, let's go out of just the outer layer that just generate the tokens for us there, and we should go and measure how deep a model think, not just how long. So we should go to the inner layers to see what's going on when we have a token getting generated, how different layers get influenced by the calculation. Is it changing the distribution of the probability of that token significantly or not necessary? So now we are really getting into understanding how deep the model is thinking for generating that token, not just naively considering the length of the answer. In order to understand that, they did something very interesting. So they started to see, well, some tokens, they need extended internal calculation to get stabilized and produce it as an answer. So we call those deep mode. And I'll tell you that how they calculate that specifically. But check out this very interesting heat map. You can see that as we go all the way to up, if you follow my pointer, these are different layers of the model. Now we are considering the last 35 layers of a given, let's say, open source model that you use. All right. And now here we have the answer of the model getting generated, and we need to check which one are deep token. That means model really thought thoroughly to generate that versus the ones that was easy. So you can see that if the color is darker, that means the model did a deep thinking compared to the other ones. For example, here something like boxed, that was easy for the model to generate that. So you can see that immediately here within just layer 11 all the way to the 35, the model was suddenly understood that, okay, I'm stabilized that the next token should be box, so the rest are lighter colors. But some other colored tokens, let's say some mathematical notations like 5 plus equal 8. These are the tokens that needed deep thinking, and you can see that it took multiple layers to get stabilized to finally generate an answer. So that proved that some specific tokens, specifically the ones that are dealing with mathematical calculation stuff, are harder for the model. More layers need significant calculation, and each layer by itself, the answer is different than the previous layer. So that means each layer is really tuning the answer because the model is not certain yet what should be the token, versus some other easy to guess tokens like is, the, and, or box here, just as an example. Now let's see how they calculate if a token was a deep one and model really thought thoroughly to generate that or not. So in model forward pass, we have multiple layers, right? We said that if a token is simple, that doesn't need heavy thinking, even the initial layers will stabilize and understand what's going to be the next token. So that means that predictive distribution of that initial layers will be close to the final layers as well. So those predictive distribution won't change that much. And in order to calculate the differences of these distributions, they are using a function called Jensen-Shannon divergence, or JSD. That's a way of just calculating that entropy, that change when we go through the distribution of these predictions for a given token. So if a token that has a specific, let's say, predictive distribution within the first layer, and when we go to the second layer, we don't see a significant difference of that distribution, that means the model is stabilized and it knows from the beginning that the token is A, or whatever. So it was simple. But if that JSD calculation dropped at the last layer, that means it took a while through all these layers to finally model stabilize itself, understand what's going to be the next token with a confidence. That's a deep thinking mode. So they did it across, let's say, all different, let's say the third model compared to the last model layer, the fourth layer compared to the last layer. So one by one they do so, and they apply a threshold. Let's say if JSD is less than 0.5 for the final layer, when we have stabilized everything, that means finally after all those layers we stabilize, that is considered as deep thinking token. All right, now we know the idea, we know how that deep thinking token is calculated, but how we can use it to have much more accurate AI answers, or how you can use it in any open source model that you take to see which answers is going to potentially more accurate and let the model be more accurate in general, without having all those long reasoning tokens with, again, just half a cost. So they use this deep thinking token to come up with a metric, which is called DTR, or deep thinking ratio. Very simple. That means among all the tokens in a sequence of the answer that model generated, how many of them were deep thinking tokens? Obviously, the higher is better. That means if all the tokens generated in the answer were deep thinking, that ratio is 1 or 100%. That means 100% of all the answer is deep thinking mode. Well, which is great, but it's not always realistically what's happening. So the higher the better, but with this ratio, we're going to see if an answer was generated using deep thinking mode or not necessarily. So what they did, they took a couple of open source models, which we're going to talk about that shortly, which you can do it as well. They had the same question, different use cases. I told you math, scientific questions to the model, and generate multiple answers, 25 answers for the same given question. And they will see which answers, they had the highest DTR ratio, or deep thinking ratio, compared to the other answers. And because we can see from the beginning when the model is generating the tokens that, hey, are we generating enough amount of deep token deep token types, or not necessarily? If it's not, we just cut the answer before it gets fully generated. That's the place that we save costs, and we just force the model to go to the path that we have more deep thinking tokens. So to make sure that this solution works, they apply that in a couple of different benchmarks and in different use cases with different models. They use GPT open source. They use also DeepSeek R1 with 7 billion parameter, Qwen 3 as well. And again, I told you for same question, same temperature, they asked to have the answer with 25 times. So 25 different samples per question. And here's the very interesting results. They realize that as we have more deep thinking tokens within the answer, the accuracy is much higher. So the AI answers are much accurate, and that correlation is pretty positive. So compare this metric of correlation with that longer answers the better, or chain of thoughts, which was even negative. This one is a significant breakthrough. Not only just chain of thoughts or longer answers, they also compare themselves with some other metrics or other solutions. We had, for example, something called log probability, which is the measurement of how confident a model is with the generated token. The higher is the better. That means the answer is more accurate, so that has a positive correlation. But none of them were even close to the DTR approach, and obviously token length was the worst one, which is unfortunately is the main one that everyone thinks when we talk about reasoning or deep thinking. We always think about longer models or from the aspect of their length, which is not necessarily true at all. So if you want to use it right now, this is the approach you need to take. First, start to generate, let's say, the initial 50 tokens of the answers. And your answers, for same question, you can have multiple answers, right? You don't need to complete all the answers for the same question. Just the initial 50 as an example should be enough. Step 2 is calculate DTR. Very simple, which is among all the tokens, let's say 50 you have generated so far, how many of them are from those deep thinking one? And I told you how you can calculate deep think token, which is from that divergence calculation of the distance of the distribution. Again, the math is behind the paper, but again, the math is not complex at all. I just wanted to give you the idea here. And then step 3 is early rejection. If you see that the ratio of deep thinking tokens is getting dropped to less than 50%, don't generate them. Go to the other answers. And then step 4, you have the complete answer generated that has the highest numbers of deep thinking tokens. We're doing so on average, as they noted, you have the cost. Just 50% reduction in inferencing cost happens with just simple metric calculation and enforcing the model to generate the one that has most deep thinking tokens. And this is the approach they call it think at n. They compare that again with some other metrics or solutions. You can see the cost was dramatically decreased, while the accuracy was higher compared to the other ones. For both model series, GPUOSS and Qwen 3, you can see that this one, the light blue, is on the top with the lowest amount of cost. Alright, to conclude, what's the key takeaway here? First of all, stop thinking about rewarding based on just verbosity or the length. So raw token counts are unreliable and encourage overthinking, and overthinking harm the accuracy of the model. Second, measure mechanistic efforts. So that deep thinking ratio we just talked about, truly go to the layers of the model, and that's what we call it deep thinking. The one that truly challenged the model with much more extended inner calculation of the layers to produce that token. This is what we consider as deep thinking here. And then scale efficiency. So early rejections of the answers with that new deep thinking token ratio will drop the cost to have. That will significantly increase also the accuracy of the answer. Alright, that was all about this research paper that says think deep, not just long. I hope you found this video helpful. If yes, I would be very thankful if you click on like icon and make sure you share your thoughts, questions in comment section below, and subscribe so you won't miss the next video. Thank you so much.